talk is about Chrome's performance tool. So Chrome actually has a built-in performance tool, if you have seen it or not. It's actually very, very powerful. So one of the things you can actually do is you can see if you do anything related to animation, even if it's from first load, you can actually see how much time, like how much network request it's doing, how much frames is actually, and if it's able to do 30 FPS, 60 FPS, you can see the timings, you can see the main thread, how much work the JavaScript is doing, and see how much work the GPU is working, as well as a compositor for CSS, so you have a lot of reflows. So one of the things we did at my previous company when I was at Standard Cognition was we built this little 3D library to actually, we used it for a bunch of things, but one of the things we wanted to do was we wanted to render 3D people in 3D space at 60 FPS. As people bought stuff in our store, we could actually, we have a virtual store where you can actually render people. So one of the things we have was that we saw some performance issues and we weren't quite sure why. So I'll switch over to the demo. I don't think it'll be as nice over over screen sharing, but you can see that there's a bit of a lag here. And if you wanted to figure out why, you using the perf tool would be one of the best ways to go in. So for example, if you can go to the performance tool, you can click record and give it like 5 seconds of data. It will start recording for every second. And once you stop, it will give you a breakdown of what actually happened within that 5 seconds. So give it a second to load. As you can see, so the UI is a bit difficult to see, but you can see there are frames, each frame what's going on. And within each frame, there's an animation frame file, which is like for, it's trying to render an animation, it will use the animation frame. And as you can see, the animation frame takes around 31 milliseconds. So that's actually a bit too long. You can't actually run at 60 FPS at that rate. So what you want to be able to see is you can come down. These are usually the React life cycle. And if you keep coming down, you can actually see what it's trying to do inside this flame shard. So for example, this is because I know this code, there's this thing called slow spheres that is kind of slow. So each time it's trying to render a sphere, it actually needs to create a new mesh. It needs to actually update the mesh. So because the way JavaScript works, that's done sequentially. And in here, there's about like 100 spheres. So it has to go through each little sphere sequentially, and it takes up quite a bit of time. So one of the fixes we can do for this one is to actually use Three.js directly. So I think I can talk about this tool later, but one of the fixes, we can actually use a faster implementation of this, and you can actually see here it's actually running 60 FPS. And if you actually go into an inspector and you do the performance, the performance profile again, you can see that it's actually able to render at 60 FPS. Well, I think I might have crashed my browser.
That's Chrome for you.
Yeah, I think it's Chrome and screen sharing at the same time. Yeah, you can see that it's lagging, but oh well. Yeah, it's lagging. The computer is lagging because of Chrome, but yep. So that's the idea. And if you're not familiar with these fire graphs, it's basically the top level functions are on top. Sorry, the top level functions are on top, and it keeps coming down, and you can see the breakdown of what it's calling. It's nice in JavaScript because JavaScript main thread is actually a single process, and everything has to happen one at a time. So you can actually drill down, see what's slow. If you have a slow method, you can actually probably see. I don't have an example here, but you can see that one method might be slow, and you can actually drill down into why that method's slow, and you can actually do optimization. And once you remove those bottlenecks, you should be able to see something like this, where each render is now under 16 milliseconds, so you can actually do 60 FPS. So for example, in the code we had just now, using a React component, sometimes it's kind of slow. So React is actually pretty fast in general, but if you're trying to update things 60 times a second, the React lifecycle does get in the way. So for example, if you're doing 3D rendering, if you avoid the React component and just use 3JS or what's it called, React 3 Fiber directly, you usually get a little bit better performance. And then this is not just for 3D. You can actually use it for page load and other things as well. And one of the nice things is that if you run the performance, you can actually compare it pretty easily if you actually made an improvement or not. And some tricks that I've learned was if you use DOM elements, usually those would actually render faster. And if you have things that requires a lot of computation or is kind of slow, actually using React Memo would actually help save some re-renders. So one of the things in React is if you have a parent and it re-renders, then usually the children also end up getting re-rendered. So if you have a parent that's memoized, then it won't actually trigger a re-render down that chain. So yeah, that's pretty much all I have.
Okay, any questions? All right, until you figure something out, I have a question. Can you hear me? Can you hear us? Okay, so you said using the React component kind of slowed things down. So is that, do you mean the implementation of the React component was kind of buggy, or the component itself provide or introduce some kind of overhead?
So the way React works is there's a bit of overhead. So when you, the way React understands if a React component is updated or not is by actually checking every object. Every component to see if it's updated. So it has to go through that list. But because JavaScript is single-threaded, it can't actually go through them in parallel. So for every time you want to re-render, it has to go through every component. So that's why if you memorize it, then it stops checking the children. But if you have everything at the same level, if you have 100 circles, and then you want to be able to update everything by, let's say, 1 pixel, then it has to actually go through each one by one. So if you run it on dev mode, it's a bit slower. If you do it in production mode, like it's a bit faster. But at the same time, like you do hit some performance penalties for having a lot of components.
Makes sense.
It's not a problem in general. Only if you want to do 60 FPS.
Great. Any question? Okay, I have another one. So in your debugging in the tool, it showed slow sphere, which is kind of a pretty name for the components. It's the same component name. So did you have to provide a source map for your production build as well to make it visible in the performance tool, or was it some kind of?
You can provide a source map. I usually do it for the debug build because it keeps the component names. If I recall correctly, it's been a while as well. If you use it on production, it works, but you might lose some of the class names, and it's a bit hard to go through because you don't have the class names.
Sure.
But it does have the source map, so if you click on it, you can still go to the source. But it's a bit more difficult to debug.
Okay. Thank you very much. Okay, any more questions? Okay, very good. Thank you very much, Mayt.